All right, so over here, I've got an empty folder. This is going to be used for my Git repository. I'm going to be manipulating this during today's lecture. And then I also want a separate folder just for notes. CD2 demos. We are in week 12. Wow, time flies. 12, day 1, Git 2. All right, so we got a file for our notes. I'm not sure how many notes will be taken, but if I need to write anything down that I want you all to remember, this is probably where it's going to go. Because a lot of what I'm going to be doing today is just going to be interactive right in my terminal. All right. So I've got a place to write notes. I've got an empty folder that will become a Git repository. So I'm ready to get started now. And I'm just going to let you know, if anyone wants to follow along, this would probably be a good lesson to follow along with. We're just going to type out a series of Git commands and kind of learn what they do. And you should all be able to just type out the same commands as me to get the same project at the end of it. So if you want to follow along, if you're that type of person, this is probably a good opportunity to do so. If you don't want to follow along, you would rather just watch and listen, ask questions, that is also fine. Does anyone have any questions before we begin? No? Okay. So going to be a few different sections to today's lecture. First, we're just going to talk about working with one local branch. Later on today, we're going to learn about branching on multiple different branches and working with remote repositories. But right now, we're just worried about working with a single branch on our local machine. So first thing I need to do is I've CD'd into my folder. I'm going to do a quick ls, make sure that it's actually empty, the -a, see the hidden files, and there's actually nothing here. So I'm going to create a Git repository using git init. So that creates an empty Git repository. If I do ls-a, I can now see this .git folder here. That's how I know that this folder is being tracked by Git. It's a Git repository. I have a Git status, and it's telling me some basic information. I'm on the master branch. There are no commits yet. There's nothing to commit because I don't have any files in this Git repository. But at least Git does know that this is a repository. When I type Git status, Git knows what I'm talking about. Whereas, if I'm just in some other folder, not a Git repository. So going back over here. So I'm going to create a file. So we've actually got something to track in Git. For clarity, I'm going to call this first file firstfile.txt. And now we're going to add some text to this first file. I could do this at the command line, but why don't I actually just open this up in my editor just for more clarity. And I guess as long as I'm opening this in my editor, I might as well use VS Code's terminal. I thought I was going to do this all from the regular terminal, but maybe that doesn't make sense. Anyways. All right, so I've got my first file. It's empty currently. I'm going to add some text to it. And then I will save the file. So now when I type git status, I'm getting some different information. It's telling me I have an untracked file. There's a whole new file, first file.txt, that Git has not seen before, has not been included in any commits. So can anyone just remind me real quick, how do I commit these changes that I've made? How do I create my first commit that includes this file with this text?
You can do git add dot.
Yeah.
And it.
So git add dot is going to add all of the files in this current folder to my staging area. That is, I'm preparing to commit them. So we git add dot. What does status tell us now? Now, instead of untracked files, we have changes to be committed. So Git knows that I want to commit some stuff. I've told it what to commit. I just need to actually do the commit. Git commit, and I need a message for my commit. I'm going to describe what I did. Cool. Git status says I'm on the master branch. Nothing to commit, working tree is clean. So working tree clean just means that I have committed all the changes that I've made since the last time I made changes. All right, so let's try this again. Gonna, go through the motions one more time. We continue doing work. I'm gonna add a second line of text to our first file. And now let's see what we've done. I'm going to use Git Diff to compare the difference between, well, let's just run it and we'll see what it is. So I just type Git Diff with no other arguments, and it's telling me second line of text was added. This output is maybe a little bit misleading because it's showing me that between the most recent commit and my current working directory, this first line was removed, and then an identical line was added, but then also this new line was added. So this part is maybe a little bit misleading. Interesting part here is second line of text. This got added here. So by running Git Diff, I'm able to see the difference between my current commit and the changes I've made since then. So I'm just making a note about that. So it compares the most recent commit against your working directory, meaning the changes you have made since that most recent commit. So I find that pretty useful. If I've been doing a bunch of work for the past couple hours, and I've really got my head down, and then afterwards it was all just kind of a blur, like what did I just do? And I want to kind of review my afternoon. I'll just do a quick Git Diff, and it'll tell me the most recent things I've added. So now let's see another way of looking at what I've done. I'm going to use Git Log. So what Git Log does, actually, let's commit this first, and then I'll show you Git Log. So Git Status, showing me the same thing as before. I've got this untracked changes. Yeah, changes not staged for commit. Need to stage these to tell Git what I want to commit. Git add dot, Git commit -m. Edit second line of text. So now Git Log shows me two commits. So Git Log is going to show you the parent commit, and then it's going to show you your current commit, and then that commit's parent and its parent's parent all the way back as far as it can go. So in this case, that's going to show us every commit in the repo because we only have one branch. There's only one series of commits. But if you have multiple branches, then Git Log by default doesn't actually show you all of them. But here we can see plenty of useful and interesting things. So we can see our two commits that I've done so far, and the messages here, added the first line of text, added the second line of text. But also I want to point out that all of our commits have labels. There are different ways that we can refer to these commits. So the primary label is this commit ID. It's this big, hash, whatever. They've each got a unique commit ID, and this never changes. This is a permanent label for this commit. One second. So the commit ID is a permanent label, but you'll note that they've got other labels here, such as head. So head is a label for a commit that always refers to your current active commit. So in Git, at any point in time, there's always one commit that is checked out. That's your current one that you're using. So that's your head. And then also, master is another label for a commit. So right now, we're creating commits in the master branch. That's the default branch before you've created any other branch. And so while I'm creating commits in this branch, the most recent commit that I create is going to get this label master. And then when I create a new commit, this label of master is going to move again to that most recent commit in the master branch. So we can use these labels with Git Diff if I want to compare a specific commit. So when I call Git Diff with one argument, passing in a commit ID, Git will compare the most recent commit or my current checked out commit against the commit that I name. So I'm just going to copy this commit ID, say Git Diff, this whole ID here. And then Git is going to compare my head commit against the commit that I just labeled using the commit ID. So here it's showing me basically the same thing that we saw before. I just kind of asked for the information in a slightly different way. So showing me the difference between my current commit and this commit. Now, just for your convenience, you don't actually have to type out the entire commit ID. You only need to type out enough to make it unambiguous. So instead of this whole thing, I could probably just type out like 64624. Oh, I guess that's not quite long enough. 6248. Yeah, okay. Because there's only 2 commits in this Git repository. So I don't need to type out the entire commit hash for Git to know what I'm talking about. Just the first 4 numbers are enough in this situation. But there are even more ways that I can refer to these commits. So there are relative commit labels that let you refer to a commit relative to another commit. So, for example, let's say I do Git Diff head. What do people expect that that is going to show me?
Going to show you the head compared to itself?
Yeah. So what kind of a diff would we see there?
Nothing, or
Yeah.
changes.
So
Maybe
yeah,
only if you typed something from when you last committed.
so when I use git diff with this one argument specifying a commit label, that compares my most recent commit to the one that I label, to the one that I name here. But remember, my most recent commit is always head. So saying git diff head is just comparing head against itself. So it's never going to be an interesting command. However, we can add a relative label onto head to compare to something else. So for example, the most common example is git diff head tilde. Let's say tilde 1. This means the parent commit of head. So this is doing the same thing that we saw before, comparing our head with the commit one before it. But now, instead of naming a specific commit, this literally just means the one commit before head. So head tilde or head tilde 1 both mean one commit before head. You might also see head tilde tilde or head tilde 2 means two commits before head. Excuse me. So this is not the same as see. I'm going to rephrase this actually. Okay, so in contrast, there's stuff like caret, which means, let's see, first parent of head. But then if you do head caret 2, this means second parent of head. So people get these mixed up because head caret does the same thing as head tilde. It's the first parent of head. But when you start going beyond the first, it becomes more clear what the difference is. The tilde is going up generations, whereas the caret is going across the siblings. So if you want to get like the grandparent commit, that's head tilde 2, the great grandparent is head tilde 3. But if you are dealing with a merge commit, your commit might have multiple parents. Normally, commit only has one parent, but a merge commit might have multiple parents. So if you're trying to refer to a commit that was created as a result of a merge, and this is actually like the second parent of some other commit, then you'll need to use head caret 2 in order to refer to that. Not a super common need. I just feel the need to point this out because a lot of people misunderstand these and they use them incorrectly. They think they're interchangeable, but they don't actually do the same thing in most in all cases. So that's just common gotcha, I think, that I want you all to be aware of.
You got a typo on line 13 normally.
Nominally, is that not how you spell it? Okay. So yeah, I showed you Git Diff head. That works. Okay, so I talked about how there's this concept of a current active commit. There is one commit that is checked out, that's our head, which by default is on the most recent commit of our current branch. But we can change that. We can check out a different commit. So I'm going to show you the git checkout command that lets us change our head. So this is kind of how we go back in time. Git checkout head ~1. This is going to change our head from this commit to this commit. So let me just show you first the Git log. So now it's only showing us one commit because, like I said before, Git log only shows you your current commit and then back. It doesn't actually show you the whole repo. So since I'm back in time from the most recent commit, it doesn't show me the most recent commit. It just shows me that commit 6248 is my head. But this is not the master commit because master is still in the present. It's the descendant of this commit, but I've moved my head back. I've moved head to the commit where I added the first line of text. And now one other thing that I want to point out about this command that I just ran is immediately after I did this checkout command to switch to this previous commit, I get this kind of scary looking warning from Git saying that I'm in detached head state. I can look around and make experimental changes, and then I can discard any commits without impacting any other branches by switching back. Because everything I do in this state is supposed to be temporary. It's just for exploring, looking around, but I can't actually make permanent changes. So the idea is kind of like, when I'm in detached head, it's like I've gone back in time with a time machine. But if you change anything when you go back in time, it like might create a time travel paradox and mess up the future. So I don't know if you've seen any of those episodes of like The Simpsons or Futurama or whatever, you know, they go back in time, someone like steps on a bug and then they go back into the future, and then like Earth is ruled by lizard people or whatever. You know, they've done some small inconsequential thing and it completely changes the future. So that's kind of the idea here, except Git is a little bit smarter than that, and it actually won't even let you make permanent changes when you go back in time. So that's really what this detached head is about, just letting you know that your current head is not in the present on any particular branch, and so you can't actually make permanent changes. This is just for letting you see how things were in the past. So you may have noticed that when I checked out this commit, it changed my repo. The first file has been modified, so it no longer has that second line of text. It just has that first line of text. So yeah, being in detached head state isn't necessarily like bad, but you can't like do work in that state. So it's probably not what you want unless you're just looking around at things.
So can you actually type in there? It just won't when you like, if you try to commit it, it won't allow you. Is that how it works?
Right. When you try to commit in detached head state, it doesn't work how you think it would normally. Or I think when you leave that commit, like when you check out the regular commit again, like master, the head, I'm sorry, when you check out master, something that's in the present, it discards your old commits that you made in detached head state. So I think they're just deleted. They're just like dead and gone. I've never actually done that, to be honest, and I'm kind of afraid to do it now out of fear of messing up the demo. But it is a good question. Michael, you have a question?
Yeah, so kind of going off that, if you were to make changes on a previous commit, can you just save it to another branch?
Yeah, that's the recommendation, actually. So yeah, if you do make changes and you like what you've done, then you can make a new branch with those changes. And then you can like merge that branch into some other present commit the normal way you do so in Git, which will be covered later in this lecture. Sound good? Cool. So Git status. So I've been looking around in detached head state, and I think I'm done here. I want to get back into the present. So I'm going to use git checkout master, and that is going to move my head back into the present to the tip of the master branch. So now you can see in my file has been restored back to what it was before. I do git status. It's going to show me I'm on branch master, nothing commit, working tree clean, not in detached head state anymore. So that's great. So let's do some more work. Going to add a third line of text. Save this file. Do another git status. It's telling me, I've got these unsaved changes here. Great. Git diff. It's showing me I've added a third line of text. Cool. Just a second. But let's say I don't actually like this work I've done. So yeah, so git status is showing me I have changes that are not yet staged. And let's say this was actually a mistake in this case. Let's just say hypothetically, this is not the code I want to write, but it's a good thing that I caught this before I commit. So in that case, I'm going to do a hard reset. Git reset -- hard. So what this is going to do is just erase all the changes I have made since my last commit. So make sure that there's nothing that you want after your last commit, because this is going to delete it basically. So I do the hard reset, and then I have lost that last line. All of the work that I made since I committed, it is now gone. Okay, so that's something I do occasionally. If like I'm trying to solve a problem and I think I have a plan and I'm not sure if it's going to work, so I just like try something out for 20 minutes, and then I realize afterwards like that was completely wrong. Like I took the exact wrong approach, and I'm almost like embarrassed that I thought of it, and I want to forget that I even tried it. So I'm just going to do a hard reset to get back to my last commit and just forget about all the work I did since I committed. But let's imagine a slightly different situation. Okay, so let's say my mistake was already committed. So in this case, I'm looking at the Git log. Let's say I decide in hindsight that this second line of text was a mistake. I should not have added this, and I want to delete this commit entirely. And this commit here, this should actually be the most recent commit. So I'm going to do something a little dangerous. You git reset -- hard, and then now I'm going to name a commit. I'm going to say head ~1. So this is going to do something quite different, actually. So with a hard reset, when you name a specific commit, it makes this named commit my new head. It's going to make this the new tip of the master branch, and everything after it just gets deleted. Like hard deleted, it's dead and gone. It's not in my trash. It's just mostly unrecoverable. It's not actually 100% true, but I'm not going to quite get into how to recover it at this point. I think you're actually going to learn about that in the workshop on Thursday. So it's pretty cool. But you should assume that this is largely permanent, and you should definitely avoid doing this when possible. Because this is one of the very few commands in Git that will rewrite your history. Generally speaking, in Git, you never want to change previous commits. You only want to make new commits that go forward into the future. So this hard reset is definitely something you want to be very careful about, because if you are rewriting history on a shared code base, that's going to confuse the other people that you're sharing the code with. When, you know, things that they thought were settled history events in the past, you're rewriting them as they're pulling down changes. And so that just gives everyone terrible merge conflicts. Anyways, so if we do git log now, we can see I've just got this one commit where we added the first line of text. That second line of text just doesn't exist anymore. That commit doesn't exist anymore. If I, had really critical work in there that I got rid of, I could really be in trouble now. So definitely be very careful using a hard reset. All right, so I feel like I need to tell you about hard reset, but honestly, you should not be using this very often. And it should be like kind of a red flag if you see other people using it very commonly. All right, so now let's add another file to our repo. Touch second file .txt. Git add dot. Git -m, second file. All right, let's get some more files in here. Just make this interesting. All right, now we'll look at the log again. So we've got 3 commits. This first one is adding that first line of text into the first file. And then the second commit adds the second file. Third commit adds the third file. And then here we are with the head and master labels, both pointing to this third commit. See our 3 files in the file explorer there. So now we're going to learn about another way that we can kind of go back in time I'm going to show you the command git revert. So git revert lets you undo a specific single commit. So git revert is one way that we undo changes, but it doesn't actually move you into the past. Git revert creates a new commit that is the opposite of the commit that you named. So it's still moving us forward into the future. It just does something that's the opposite of something else. So in theory, it should basically remove that commit from the project, except you can still see it in the history, so you can move back to it. So let's see an example of that. I'm going to do git revert head_1. So let's make some predictions real quick. What are we expecting my project is going to look like after I revert this commit?
Will your third file go away? Or your, third file?
The second file go away.
Well, so for starters, which commit is head_1?
The one with second file.
Yeah, it's this guy. So we're going to create a new commit that should be the opposite of this commit. So let's see that happen. So it's asking me to write a commit message. So I'm just going to use the default commit message of revert second file. I think the default commit message is just revert, and then in quotes, the commit message of the commit you're reverting. So this was the message for that second commit. So it's not too creative. So I'm just going to save this file. WQ is how you save and quit in Vim. So now I'm going to do a quick git log over here. And so now I have 4 commits. First line of text in the first file, second file, third file, and then reverts second file, reverts this commit. So, from Git's perspective, I haven't really gone back in time. I've just created a new commit, a 4th commit, moving further forward into the future. But kind of conceptually looking at our project, it feels like, we've undone something. We've gone to the past, we undid this commit, so we no longer have this second file. But something really important to point out is that the repo is now in a new state that it has never been in before, because we did this other commit, this third file, this third commit after the second commit. Reverting this second commit doesn't undo everything after it, so it doesn't make the whole project look the way it did at this time. It just undoes this one piece of work surgically. So I think this is a really important point that some people don't appreciate fully. I've had frustrations recently with a say, semi-technical project manager, which is in some ways worse than a non-technical project manager, because we would have issues where, we would deploy the application and then it would get a bug in production and, it would crash, people couldn't use it or whatever, and we would identify the problem as having come from one particular commit. And so like this project manager would just like panic, like chicken with its head cut off, and say, just revert that commit and then redeploy it. And I would try to explain to him, like, after we revert that one commit, like we can't just like immediately redeploy and then everything's good. We have to test it again, go through our whole complex testing procedure with like everyone involved or whatever, because after you revert that one commit, like the project is again in a new and untested state. And so we have to go through all of our tests to make sure it's good. Like he was under the impression that reverting the problematic commit, takes us back into a safe, stable, and known state, which is just not true. So just something to be aware of. Reverting a single commit, like your project didn't exist in the past without that one commit, or with the other things after it. So you've created a new state for your project. Just be careful, make sure you know what you're doing. Make sure you test what you're doing. Alicia?
So like, would an example of that be? Like, let's say commit, 1 was making a button and that's all it was, or, whatever commit number was just making a button. But then after that, you add, like what happens if work after that edited that content? So like if you added an on click to that button that had, a function and everything, and then you reverted the commit that just made the button, then I guess the button would be gone and then all that functionality would be as well, because it's not tied to anything any longer.
The button would either be gone or you would get merge conflicts that somebody would have to deal with. So either way, it would be bad. That's part of why we recommend that like every commit just has kind of like one logical isolated feature in it. And then after you do that, like one thing, you commit, and then the next feature is on a different commit. So that way, if you need to remove some specific feature, you can do it commit by commit. Because otherwise, if you have a whole bunch of unrelated work in one commit, it's really hard to revert something that was problematic without also removing things that you want to keep. So the kind of follow-up on this is if you have some commit in the past and you want to make your entire repo look like it did at that commit, it's possible to revert an entire range of commits. You can say like, hey, revert from head to this commit in the past, all the commits in order. And so that actually does what you want it to. It'll make your project look like it did at that point in the past. But I actually don't like doing that so much. I think there are easier ways to go back in time. So I'm going to show you some of that real quick. Let me think, how do I want to do this? Okay, so let's look at where we are right now. Git log shows we've got 4 commits. This most recent one has only 2 files. The second most recent one, though, should have had 3 files. Now, let's say I maybe want to go back in time to this commit with the 3 files. I'm not sure, but maybe I do. I kind of cautiously, hesitantly want to check it out. So I'm going to use git checkout again, but with a different syntax. This time I'm going to call git checkout with an extra argument. I say git checkout head tilde 1 dot. So this period refers to my folder. I'm saying the entire project. Make my entire project look the way that it did in this commit. So this is very different from the other way that we use checkout. So this is different from the previous way I showed you checkout. So the simple way of using checkout, where you just name a commit, it just moves your head, moves that head label to the commit that you named. And then that becomes your current checked out commit. And it also changes the files in your working tree to match that commit. However, when you say a commit and then also a folder in your project, it doesn't move the head, does not change your current commit. It only changes the files in your working tree. So actually, before I run this command, so I do git status on the master branch, no changes to commit. And then I will git checkout head ~1 dot. And here it tells me it is updated one path. You can see in the file explorer, the second file has been added back in. And if I do a git status, it tells me I have changes to be committed. If I do a git log, nothing's changed in the log. So running git checkout with that extra argument did not change the log. I still have 4 commits. The 4th commit is still the checked out commit. This is my head, this is my master, but it has changed the files in my working directory. So if I like the changes that just happened, then I can commit this using git commit just the way I normally do. If I don't like the changes that just got introduced from git checkout, how can I get rid of these? I know you know this.
Git reset hard.
Yeah. So I just kind of wanted to see, what this looked like. Where was it? I wanted to see, what my project would look like back in head ~1. So I've kind of recreated all those files in my current commit. So if I don't like it, I can just git reset -- hard, not naming a specific commit, just the regular hard reset. And then that deletes the file. Didn't change the log because I didn't name a specific commit. It just cleared out all the changes to my working tree that had not been committed.
So since you didn't change your head, could you have also just done git checkout head? Or no?
You're saying like here at this
I
point?
mean, instead of the reset, since your head commit didn't change, could you have just done git checkout head and then it would have been back the way it was?
No, because currently head is the checked out commit. So saying git checkout head is just kind of reiterating something that's already true. So that doesn't do anything. It's like cd dot just moves you into the folder you're already in. Git checkout head, it just sets your current checked out commit to be the current checked out commit.
I thought you said though that git checkout, the head ~1 doesn't change your head.
It's when you use checkout with the extra argument.
Well, yeah, I mean, sorry, with the dot as well.
Mm-hmm.
So I thought it didn't move your head, so that's why I was thinking you could just do. Git
Oh,
check
so
it.
hold on, you're saying. Hold on. So here I've got uncommitted changes. But this one is still, so if I just git checkout head dot. I actually did expect that to work, but it looks like it doesn't.
So I meant like, okay. All right.
Yeah, I know. So I guess if I wanted to get rid of these changes, like I was saying, I would have to do the hard reset to get rid of my uncommitted changes and make it back to how it was in this head commit. But let's say I do actually like it. And so I want to commit these changes. So I can just commit like normally, git commit -m. Cool. So now Git Status tells me I'm on master, everything is clean. Git Log shows me I've got 4 commits. Head is in the present, so we're not in detached head or anything. And everything looks good. I'm ready to do more work. So this is the end of the first section of today's lecture. This is as much as I have to tell you about working on single branches in Git. I think we're about due for a break. And then when we come back, I want to show you some tips for working on multiple branches. But do people have any questions about what we've covered so far before we build on it after the break?
Caleb had a question in the chat.
So if you delete a file, you commit. So none of this has to do with GitHub, really, at this point. If you delete a file, you committed it, you could, just revert that commit on your local machine. And then that creates a new commit with that file added back in. And then just whenever you push up to GitHub, it's going to get that extra commit where you added it back in. So yeah, the GitHub is not going to be bothered too much about any of these changes. It just sees like new commits added after old commits. All right, what other questions do we have? No other questions? All right, so it's 10:10. Let's take a 10-minute break. Come back at 10:20, and we will talk about working with Git on multiple branches. All right, I'm still sharing my screen. So yeah. So next, we're going to be learning about working with multiple branches in Git. So first, we're going to learn the most basic command for inspecting our branches, git branch. So it doesn't show us too much right now. It just shows us our current branches. By default, we only have one branch called master. So now I'm going to make another branch just so we've got something to compare it to. So I made a new branch. So now if I type git branch, we can see that I have 2 branches. Got the master branch, and this one has an asterisk next to it, indicating that that's my current checked out branch. And then I've got this other branch that I just created. But I just noticed that I misspelled this branch name here. So I'm going to delete that real quick. Git branch -d is the flag to delete a branch. Now I'll recreate that with the actual correct name that I intended. Git branch develop. Cool. So now I'm going to use the log. I'm going to use Git log to check out our branch. Hey guys, can we keep the side conversation to a minimum? If we could, thanks. So I'm going to use the Git log again, but I'm going to add some extra arguments that'll give us some more information. It'll be useful as we're inspecting our branches here. I'm going to do git log -- graph -- all to see all of our branches. Decorate equals full. Okay, so now we get a little bit more information in our Git log. It's showing us an asterisk for each commit, showing us a line connecting each commit to its parent commit. And we can see on our head here, it's got the head label, but it's also got the master label, and it's got this develop label. So I've created a new branch, but I haven't added any new code to that new branch. It's really just another label that I've created for the same commit. So we see what I'm saying here? This one commit has multiple labels on it. It's, BF6F1, it's head, it's also master, and it's also develop. It's creating more labels for this one branch. And note also that head is pointing to master. So that's saying that if I make a new commit, it's going to be on the master branch. So now I'm going to switch my branch from master to develop. I'm going to git checkout develop. Switch to branch develop. Now I'm going to do that git log command again. So now this looks almost exactly the same, but with one minor change. Now we can see that head refers to develop instead of pointing directly to master. Now, these are all labels for the same commit, but this is showing us that if I create a new commit right now, I would be committing to develop, not to master. All right, so let's create some more commits on these branches. So we've got some more interesting stuff to look at. Going to touch devfile.txt. Because yeah, we are on the develop branch right now. So I created devfile.txt. I'm going to add it. Added a file in the dev branch. Great. So now if I want to compare what I just did in the develop branch with the current state of the master branch, how can I compare these two things?
Maybe Git Diff and then the opposite of whichever one you have checked out.
Right, so I've got develop checked out.
So Git Diff master maybe.
So yeah, it's telling me that there was a new file, devfile.txt, was added. So that's what Git Diff is showing me here. So that's cool. So now if I want to merge these changes together, the command that I'm going to use is Git Merge. But before I merge anything, let's look at the log again. So now develop is in the future, or it's in the present, I should say. And then master is one commit behind. They're still kind of both in the same timeline, but it's just that develop is further into the future because it's got one piece of work that master does not have. So now if I want these two branches to be the same as each other, well, let's try something. I'm going to try Git Merge master. So this command is actually going to do nothing, already up to date, because there are no new changes in master that are missing from develop. That's just how the syntax works for Git Merge, is that it's not like a two-way or bidirectional operation. It matters which commit you're on and which commit you name. So when I just ran this, I was on the develop commit, or I was on the develop branch, and I named the master branch as the one that I'm merging. And so that's going to take the new work from master and apply it to develop. If there isn't anything new in master, then just nothing happens. It doesn't like automatically make them the same as each other. Git tries to be smart and isn't going to use old changes to overwrite new changes. All right, so that did literally nothing when I typed Git Merge master. So what I have to do actually is run the merge in the other order. I have to check out the master branch and then merge develop into master. And then that is going to take the changes from develop and apply them to the master branch. But in that case, that's going to be a very simple change to make. Git doesn't even have to make a new commit. Because in that case, if I'm saying that I want master to have everything that develop has, all Git actually does is move this label. We just move this master label up onto this commit, and then Git says, yeah, okay, now the master branch has everything that the develop branch has. So I'm going to git check out master, then git merge develop. And so now this is going to actually change things. We have done a fast forward merge. So there are 3 different types of merges in Git, depending on how different the files are, depending on how different the commits are. Git has to do a different type of merge. And for the simplest situations, Git will perform a fast forward merge. So you can get a fast forward merge if one branch has new work that the other is missing, but the other one doesn't have any new work that like the first branch is missing. So like in this situation here, because master and develop are kind of on the same timeline, but develop is just one commit ahead, the develop branch has all of the work that the master branch has. It's just that the master branch doesn't have all the work that the develop branch does. So the master branch needs to be brought into the future, into the present, I should say, by merging develop in. So git merge develop creates a fast forward merge, which is the simplest type of merge in Git, doesn't even create a new commit. Did I write that out? Yeah, it does not need to create a new commit. So I should hope that all of your merges are fast forward merges because they are very easy to work with, just totally painless. But unfortunately, it's not always going to be the case. So sometimes both branches will have new work that the other branch doesn't have. So I'm going to look at the log again. So after the merge, we've again put all of the labels onto this current commit. This is how you can tell that everything is fully merged together and all of your branches are up to date with each other, is when all of the labels are on one commit, meaning that just all of our branches are the same commit currently. So I'm going to make yet another file. I'm going to touch master file. Add that. Okay, yeah. So there's master file, there's the dev file. So I'm going to move on over to my develop branch. We're going to put some text in here. We're going to commit that. All right, so let's take a look at our graph now. Okay, so now it's getting a little bit more interesting. We can see develop and master have diverged. Now each of them has some work that the other does not.
So are you seeing that they both have work that the other doesn't here on that graph, or do you just know that?
Yeah, you can see it on the graph because you can see that the commits have diverged. So they're not in the same like pathway anymore, but it like branches off slightly here. This little spot right over here. See what I'm saying?
Yeah. And wait, that one's the master. So what does that branch exactly mean though?
I mean, this is the most recent commit on the master branch. This is the most recent commit on the develop branch.
Yeah, I guess what I'm asking is that little dash right there, is that just saying this has something that your head doesn't?
Right, that it's
Okay.
branching off, it is diverged.
Okay.
So now if I want to get these two branches to be fully merged with each other, this is a little bit trickier, but still not too hard. So let's do a Git Diff just to see what we can see. Git Diff master. That should show me some interesting stuff here. Excuse me. So yeah, difference between dev and master. Dev added text in the dev file, and master has this master file.txt. So that's the difference between these two branches. Okay. So now I want to merge. Let me just check what branch am I on. I'm currently on develop. So what I want to do is apply the changes from master to my develop branch. I'm going to have to do this both ways. Actually, I'm going to first take the changes from master and apply them to develop. And then afterwards, I'm going to take the changes from develop and then apply them to master, because both of them have changes that the other doesn't. But there's a very specific reason why I'm doing it in this order, because when you resolve a merge, the first time I merge, when I merge develop into master, I might get conflicts. I might make a mess of the branch. But the second merge is going to be a fast forward merge. So we're going to see that in a minute. So I have a choice of which branch I potentially make a mess on, basically. And given that choice, I would rather potentially make a mess on the develop branch than the master branch, because the master branch must always be pristine and immaculate. It should always be working functional code that can be deployed at any time. And that should also be true of the develop branch, but not quite to the same extent. So if I'm going to choose, which branch to make a mess on, I would rather that potentially happen on the develop branch and definitely not on the master branch. So I'm checked out on develop, Git merge master. And now this time when I merge, it creates a new commit. So that's why I have to write a commit message here. Now, by default, the commit message is merge branch master into develop. I think that's a good enough message. So I'm just going to save it, just WQ, save and exit in Vim. So now it made the merge with the recursive strategy. So that's the second type of merge. Let's do a Git log, see what that looks like. So now you can see that I've kind of partially merged the branches together. They're not like totally diverged. So you can see now develop, everything has converged back into develop. So this branch has all of the work that has been done in this project, but the master branch does not. So if I check out develop, I'm going to see everything that was done on the master branch because it got merged into develop over here. But when I check out master, it doesn't yet have everything that was done on develop because I haven't merged develop into master yet, which would move this label up into the present here. So let's see that real quick. So yeah, I just merged master into develop. That created a new commit. So that's this here. This is our merge commit. It has two parents, so this commit and this commit are both parents of this commit, which doesn't usually happen. Git commits usually reproduce asexually. So this is one of the rare instances where a commit will have two parents. So now I'm going to check out the master branch. And I'm going to do the merge the other way, Git merge develop. Now, given that I just merged master into develop, I know that when I merge develop into master, this is going to be a fast forward merge. So I already did the complicated parts of the merging. This is just moving labels. Cool. So I got a fast forward merge, I had to move some labels, make some tiny changes to the dev file, but now we're all up to date. So this is our updated Git graph. The branches have converged again, and this most recent commit has all the labels on it because this is our present. And everything is up to date. Okay, so when each branch has changes that the other doesn't, you can do a recursive merge, which does create a new commit. But it's still not so bad because Git is able to do this for you automatically. So you do have to create a new commit, and it changes the history. You need to be aware of it, but at least you don't have to manually merge the files together. You don't have to tell Git what the output should be. It figures it out for you. So that's not so bad. What is so bad are merge conflicts. I hope that you never have to deal with these, but inevitably it's probably gonna happen to you sooner rather than later. So let's learn how to deal with that now. Let's see, what branch are we on? We're on master. So I'm gonna add some text into the first file. Say master says yes. Gonna git add. And we're going to go to develop. And then we're going to put some different text in here. Develop says no. And then we're going to add and commit. Do a git diff. So now we've got some trouble. Both of our commits have different changes to the same line of code. So in this case, Git has no way of knowing what is correct. Because both of the commits that we're trying to merge together are telling Git conflicting information. They're saying that this exact one line of text should be two different things. So there's just no way Git can figure out what you meant. So here, if we try to merge, we're going to get some conflicts. So we're on the develop branch. So I'm going to merge master into develop. And this is going to give me merge conflicts. So it definitely is not good, but it's not so scary. Just got to read. It'll tell you it's automatically trying to merge things, trying to auto merge things. But when it gets a conflict, it'll tell you where. It tells you which files have the conflicts. So here, there's a merge conflict in firstfile.txt. So I open up that file in my editor. And then Git, we can see, has dumped all of this text into the file. So this text here, all these angle brackets, these equal signs, whatever, this is not valid code in any programming language. And that's kind of the point here. Git is trying to make this code invalid. It's making these files unrunnable. So it basically forces us to stop and deal with the merge conflict before we do anything else in our project. Like, we can't run the application again until we fix this merge conflict. So what Git is saying here is there's two different versions of this commit, and it doesn't know which one is right. There is the current change, which is head, and then there's the incoming change, which is master. So basically all you do is you just delete the text that isn't supposed to be here until it looks like how it's supposed to look. So let's say I know that the master version is correct. I'm just going to delete all this stuff here, and then I'll delete that thing and then just get rid of that. And when I decide that this is how it's supposed to look, I can just add and commit as usual. And if I look at my log, what can we see? Cool, looks pretty familiar. The develop branch is up to date. It's got all the changes from master, but master does not have all the changes from develop. So just like before, I'm going to check out master. And now I know that because I just resolved merge conflicts from merging master into develop, when I merge develop into master, this is just going to be a fast forward merge. Cool. So fast forwarded. If I look at the graph, we can see all the branches are fully up to date. Got all of our labels on this most recent commit. And yeah, I have resolved a merge conflict. So that's the third type of merge. Yeah, merge conflicts are probably one of the most frustrating things to deal with as a developer, or at least the least fun things to deal with as a developer. So I'm hoping you'll at least, have the skills to fix them as they occur, not suffer too much with them. Okay, so that's all I have to say about working with Git locally. We're about ready to take a break. And then when we come back, I'm going to talk about working with remote repositories. But what questions do we have about what we've seen so far before we take a break? No questions? Anything? Anybody? This is all just like makes perfect sense.
I guess I have a question, kind of off topic, but would you recommend tools like Git Kraken to kind of keep like a better visual, I think, than the console? Or what are your opinions on that?
I mean, I wouldn't recommend it, but other people do. So I've never used Git Kraken before, which is a graphical Git tool. I think it can be useful when you're just like learning Git at first, because it shows you this kind of graph showing you how everything is connected. So if you just like don't understand how Git works at all, it might be nice to have something to look at. And actually, I think we have some optional Git homework for tonight, which is like an interactive online kind of Git tutorial, and that'll show you some visualizations. And I think that can be useful. But honestly, like this visualization here is basically the same as this graph that I showed you here at the command line. It's just that's a kind of prettier version of it in Git Kraken. So if you really need to get a graphical visual representation of your repo, like you can get that at the command line. But honestly, like for most practical purposes, I feel like this kind of a view is overwhelming. Like this is just way more information than I want to be looking at. When you're looking at like a big professional project with like multiple teams of developers working on it, I would just get overwhelmed seeing all this information. So I really like using Git at the command line because you can ask Git very specific questions and it will give you a very specific answer. Like, what is the difference between this one commit and that other one commit? Or, you know, limit things to just specific files or whatever. So even though there's a lot of stuff going on, you can kind of focus on one thing at a time by just clearing your terminal and asking Git a specific question. Whereas if I had to like click through this GUI in order to figure stuff out, there's just like a lot of information here that I don't want to be reading on my screen. I mean, but that being said, if you think it's useful, then try it out. But oh, so the other caveat to that is that command line Git is really important to be comfortable with, because anything you can do with the command line, I feel like I've said this before, but anything you can do at the command line can be scripted and it can be automated. So, you know, you can like automate your Git workflow to do a whole bunch of stuff with just the press of a button or like running a single script or whatever. Whereas if you only know how to use Git through a GUI, you are condemning yourself to using your mouse and clicking through buttons and menus anytime you want to do Git stuff. So it makes it very hard to like optimize your workflow. Yeah, so we definitely recommend you primarily get comfortable with command line Git. I've certainly never used a GUI for Git of any sort, and I don't feel like I'm missing anything. And I definitely feel like it works like in the reverse, where people who don't use the command line are definitely missing something. You can, you know, be a legit developer using like graphical tools sometimes, but I just wouldn't encourage you to rely on them too much. Sorry, so that's probably more of an explanation than you wanted, but that's my opinion.
Thank you.
Yep. Any other questions?
Yeah, so earlier on, you used the command GTS. Is that an alias that you created?
Oh, yeah. I didn't mean to do that. I'm trying to show you the actual like vanilla Git commands, but sometimes I'm just trying to do something fast and I forget. So that's in my bash RC. Or is it my bash profile? Which one is it? Yeah. So I've got a bunch of aliases for stuff. So here's basic stuff, just like LSA is LS-A because I do that all the time. SL is LS because I just mistype things when I type them very quickly. Down here, I've got a whole bunch of Git aliases. So like Git Status, you know, we very commonly will Git add and then Git commit. So I just put that all in one command. Oh, and then that Git log, like I really like doing this, like I mentioned. So my alias for GL is Git log with all those flags, so I don't have to actually remember them.
Do you mind bringing that up real quick again?
Sure. Do you have any questions about it?
Oh, I'm good. I was just taking a picture.
Cool. Hope you enjoy it. All right, any other questions? No more questions. Okay, let's take a break. Come back at, let's come back at 11:05. Slightly short break. See you at 11:05, we're going to learn about remotes. See you soon. All right, where we left off, we learned how to manage multiple branches on a local repository. And so now we are going to learn how to manage multiple branches on remote repositories. So now just to remind you, a remote repository in Git is really just a Git repository that's somewhere else. Remote as in like a remote island, it's just far away from where you are currently, but it's very much a remote repository, the same as your local, it's just somewhere else. And often we might want to, register a remote repository to a local repository so that we know that, these two are supposed to stay in sync. One of them is tracking the other, something like that. So first, if we want to see what remote repositories we have for our repo, we type git remote. Now, currently, we have no remotes, so it's going to show us nothing. So why don't I create a repo in GitHub? And then I can add it as a remote. So I'm going to use my account here, create a new repo, call this Git demo. And no, of course, that name already is taken from all the other times I've done this Git demo. Let's make another Git demo. Is that okay? That is not taken. Great. It's going to be a public repository. Don't need anything else here. Great. Copy the repo URL. Now I'm going to add this repo as our remote. Say git remote add, and I will name it origin and paste in the URL. Now, of course, I can name this remote anything that I want, but it is very customary that the first remote for any given repo is called origin. So if I was onboarded to some project and they were using remotes with names other than origin, I would be very surprised and very confused, not really sure, what the actual source of truth is. So whatever that central source of truth is for your project, you call that remote origin. So now if I do git remote, it tells me I have an origin remote. If I want a little bit more information about that, I can do git remote -v. Just generally speaking, if you want more information about some command, you can pass in -v for verbose. And here it's telling me that these URLs are where I push and pull data from with this remote. So this matches up to what I expect. So that's great. If your remotes are ever not working the way you expect they should, you can do a quick git remote -v, look at the URL, make sure it is the remote you think it is. But so now what I want to do is update the remote repository with my local code. So who can tell me, how do I do that? I want to take the code on my local machine and then
Push it.
Yeah. So what is the syntax for that command?
Git push origin master.
Origin master. Okay, so this is the syntax that we've taught you so far. What we haven't mentioned, though, is that this is actually a shorthand command. We've been doing the shortcut all this time. So this here is the long form of the push command. We actually have to name two branches. The first one is the local branch, and then the second one is the remote branch. So this is saying push our local master branch onto Origin's master branch. Now, commonly, the local branch and the remote branch have the same name, which is the case here. I want to push my local master onto the remote master branch. So in that case, you don't have to name both of them. You just name the branch once, and Git will assume that the local branch and the remote branch have the same name. But it's important to know that those are technically different branches in different repos because they're on different computers. But commonly they'll have the same name. Otherwise, that would get really hard to keep track of over time. So yeah, like I was saying, that's exactly the same as this command, which does nothing because we're already up to date. So let's make another branch. So this is a mistake. Let's say I gave this branch the wrong name. You know, just kind of like at the very beginning of this demo, I made that develop branch and then I deleted it. But this is going to be an even worse mistake. Because I'm going to actually push this branch up to origin. So now I've added that oops branch to GitHub. So now if I go to GitHub, we can see, you know, this is the master branch checked out by default, and these are all the files there. But we have other branches, such as oops. It has the exact same files, but it is a separate branch, and I didn't mean to create it. So does anyone think they have any idea what command can I use to delete this branch? Using what we've learned so far in this lecture, how do we think I'm going to delete this branch off the remote repository?
Maybe the reset command.
Okay, that's a good guess, but it's not what we're not what we're going to use here. It's going to be something I mentioned in this recent
Revert?
section since we came back from the break. Someone said something?
I said revert, but that was before the break.
Right, yeah, it's not revert either.
But if you merge, it'll have the same files, so I wouldn't think that would work.
Right, I just want to delete that branch off of the remote repository.
Well, -d then,
So you're saying,
git -d branch name, -d oops. Something like that.
Push -d.
like this?
I don't know.
Looks like it doesn't.
Oh, it's git branch. So git oops -d oops, or no, git branch -d oops.
So that deletes my local branch. If I just do git branch -d oops. So that deletes it locally. Now git branch doesn't show I've got it here, but it's still on GitHub.
I guess so. Now you can add and commit to GitHub.
I mean, there's no uncommitted changes. Just that branch doesn't exist anymore. So let me show you what I'm talking about. This might seem a little bit tricky. Branch, oops. Okay, so I've recreated the oops branch. Now I already showed you the push command in git push origin, then, you know, master : master. The one on the left is the local branch, and then the one on the right is the remote branch. So if I want to just delete a remote branch, this is the syntax for that. So notice that there is nothing on the left side of the colon, and then oops is on the right. So that's saying that I am pushing nothingness, just void, onto the remote oops branch. And in Git terms, that means delete it. So now when I go back to Git, I got a 404 because this oops branch doesn't exist. So now I've only got the master branch here. All right. So yeah, I think there are actually other ways to delete remote branches as well, but I like this syntax because it just uses the command that you're already using for something else. And it's just kind of the same syntax applied to a different use case. So I think it's kind of neat.
So did you say that with the colons, the one to the left is local and to the right is remote? Is that right?
That's correct.
Thanks.
Can you put that in the notes, Raphael?
Okay, so you might notice that locally, got these 3 branches, develop master oops, I'm going to delete oops. But I've also, so I do have the develop branch that is not up here on GitHub. So I have to push these branches separately. Push origin develop. Now GitHub has it. Master and develop. So now I'm going to make some changes to one of these files on GitHub. So normally you don't edit files directly on github.com. This is just to simulate if I had a collaborator who was making changes. So that this way I can get some changes that are in the remote repo that are not on my local version. So I'm just going to change this first file. Add some edits from a collaborator there, commit that. Great. Now on my local machine, I would like to pull in these changes. But there's a couple ways I can do this. So can anyone tell me, what's your just immediate first thought? If I want to get these changes from GitHub to my local develop branch, how do I do that?
Git pull origin branch name.
What was the last bit there?
The branch name?
Yeah, so that's what we showed you at first. Git pull origin develop, and that's perfectly straightforward. That works, that's fine. But what I want to show you right now is that actually git pull is a combination of 2 different commands. So it's another one of those kind of shortcut commands. So when you do a git pull, you're actually doing 2 things in a row. The first thing you do is git fetch, which just downloads the changes from the remote repository, but does not immediately apply them to your local repository. And then the second thing is a merge, which we've already talked about that merges in the changes on the remote version of develop and then applies them to your local repository. So let's see how that works. So this could be good, like if I'm kind of concerned about the changes I'm pulling in, I think it might be bad code. And so instead of just blindly pulling in and trying to merge, I want to inspect the changes first. So I'm going to do a fetch so I can, download the changes to my local machine without merging it into my current commit. So we're gonna git fetch. And so that downloads all of the new changes from this remote repository. But now if I do a git status, nothing has changed. There's no changes in the files here. On GitHub, it says edits from a collaborator. But if I switch to my develop branch, I don't see that here. If I look at git branch, I don't see anything different here. It's just develop and master. But that's because git branch is actually not showing me all of my branches right now. So if you're wondering, where did these changes go that I just fetched, they actually went to a hidden branch. So if I want to see all of my branches, you git branch -a, just like with ls-a shows you hidden files, git branch -a shows you hidden branches. And so now we can see a couple of other options that were hidden from me before. So in addition to develop and master, I have these branches called remotes/origin develop and remotes/origin/master. These are called remote tracking branches. So these are in many ways just regular branches on my local machine, but Git updates these automatically for me. The purpose of these branches is for my local Git repository to have some understanding of what the remote looks like. This remote tracking branch is like my local repo's most recent knowledge of what the remote looked like. So this doesn't actually get updated in real time because the remote repo and the local repo are on separate computers. They don't always know about each other, but it does get updated sometimes. So when you run git fetch, what Git does is it's downloading the changes from the remote repository and then applying them to your remote tracking branch. That's basically what git fetch does, is it tells Git to update your remote tracking branches, which is just your local understanding of what the remote looks like. And then also when you push, your local repository updates the remote tracking branches because, well, you just told the remote what it looks like by pushing. So then your local knows that that's what the remote looks like because you just pushed. So it can update your remote tracking branch in that case as well. Now you might note that there are some slashes in here. That's not actually like a hierarchy. This isn't a branch inside of a branch inside of a branch. It's just the branch name has slashes in it. If I want to see what this looks like, I can check it out just like any other branch. So I can git checkout remotes/origin/develop. And now I'm in detached head state because this is not in the present anymore. But I can still check it out if I want to see what's going on. So now I can see the changes that I would get if I had just pulled or if I had merged. I see the edits from a collaborator up here in my first file, just like what I've got on the GitHub version. So now if I decide that I like this, that my collaborator's changes were good, I'm going to get out of detached head state, hit checkout develop. And then I'm going to merge the remote tracking branch into my develop branch. So I'm going to git merge mode/origin/develop. And that does a fast forward merge, applies the edits from a collaborator into the develop branch. And I probably should have thought about this a moment ago, but instead of just merging, I could have also done a diff. If I want to, at my local machine, just see the difference between my current commit and the changes I'm about to merge in, I could have done a git diff, promotes, origin, develop, which right now they're the same because I just merged, but there's a thing you can do. So now I'm going to check out master and then merge develop. Fast forward again, and now everything is up to date. Master has the edits from a collaborator.
So real quick to rewind a little bit, so you fetched it and then you did, I wrote this down. Then you did the branch -a to see all the files. And then did you do git checkout remote/origin?
Yeah, I used checkout in this first form. So that actually put me in detached head state. But I was just doing that to look around, I can run the code and see if it works.
Okay. Okay, and then you said you made a new file to commit them all to?
I didn't make any new files. But after I decided that I liked those changes, I merged them in. So I checked out develop to reattach my head, and then merged my remote tracking branch into the develop branch.
Okay,
So yeah, the new file was only created, well, actually no files were created recently. I edited a file on GitHub and then just used fetch and merge to apply that change to my local repo.
so when you're working with other people, do you always recommend doing the long way first? So like fetching?
No, I almost never do that, honestly, unless I'm like really suspicious of the changes I'm about to pull in. Usually I just blindly pull it in and trust that it's good. But I wanted to show you this just for your understanding, because I think to a lot of people, it's kind of magical. Like, how does git pull work? And, how does it know what the state of the remote is? And the answer is the remote tracking branches. Like whenever it says that you're up to date or there are changes on the remote that you don't have locally, it's because of these remote tracking branches. And that's just something on your local machine you can check out. This is just digging a little bit under the hood because I want you to just understand how Git works. Yeah, most commonly, you're just going to use pull because it's faster and more convenient.
And you couldn't have done that from the detached head state, right? You had to recheck out to the correct branch.
I'm pretty sure, yeah. I don't think you can do anything productive from detached head state.
Okay.
So yeah, again, normally we would just do git pull origin develop. That would do a fetch and then automatically merge it in. But I think it's knowing how to break that down to 2 steps, I think improves your understanding of Git. All right. Now, there's one other thing I want to mention. Don't have a demo for this, but I think it's just cool to point out. So in the time that I've been giving this demo, actually, there have been some changes to the Git API. There have been some new commands that were added. So these are kind of all the classic ways of doing things. And I think it's important that you know this just so you can communicate with other developers. You're able to like read people's Git scripts and you know what they're doing. But it's also true that for a very long time, people have complained about Git's API, just that these commands don't make any sense. And some people have wanted to change them. So in particular, Git checkout is something that people complain about a lot because these two different forms of checkout do really two different things. Git checkout here, where you just name a commit, this switches your current branch, which is very different from using Git checkout with a commit and a folder path, a file path, because that's going to restore the files in your working tree. So these are like very much different things. So in modern Git, there are actually two aliases that do each like half of what checkout does. So as a replacement for this, say git switch. And git restore is a modern replacement for this form of git checkout. So you might kind of prefer these commands, git switch and git restore, over using git checkout. Does exactly the same thing. I think that these ones actually might be a little bit smarter in some ways. They might have like better default settings in certain cases. But also just the fact that it's two different commands to do two entirely different tasks is nice, as opposed to checkout, which is one command for doing two entirely different tasks. So I think it's kind of cool that Git is very slowly, slightly modernizing itself over the years. All right, so we have one more brief section that I want to talk about in this lecture. It's not about mechanically how you use Git, but I'm going to talk about kind of practically how people use Git on teams. It's going to be pretty brief and pretty simple, but I like keeping it simple with my Git workflows. Before we move on to that last section, does anyone have any other questions? Questions? Any questions? What questions have we got? Anybody? Nobody? All right, let's move on then. We're going to talk about Git Flow. This is a branching strategy. This is generally an answer to the question of how do people actually use branches on like a real dev team? So there's a lot of ways that you could do this, but this is my favorite way to do this. This is how most of the companies I've worked at have done it, and it's by far the most effective strategy I've seen. I've seen one other strategy being used, and it was an absolute mess. I'm not even going to repeat it here. So generally, in the Git Flow branching strategy, there are two different types of branches that you're going to use. You have long-term branches and short-term branches. So the long-term branches these are pretty simple. There's exactly two of them. So for starters, you have master. This is the live production code, and it must not break. So the assumption is the assumption is that the code in the master branch is always ready to deploy. just that whoever is in charge of the deployments at your company, they should be able to deploy or redeploy the code on the master branch at any time without asking anyone else for confirmation, because that branch should always be good to go. You should never have to ask the developers like, hey, is master buggy? Is it safe to deploy it? Or is it going to bring down the entire application if I deploy master? That is just unnecessary chatter. You should never need to have that conversation, because it should just be known as a matter of process and procedure that the master branch is always immaculate and bug-free, and it's just ready to go. And sometimes, like, kind of the extreme version of that is, in some cases, the master branch is deployed automatically. So if you merge anything into master, like 10 minutes later, that's on the live website. So like, you just cannot afford to merge bad code into master. Also worth mentioning that in more recent years, this default name is changing. Nowadays, main, I think, is the more common default branch name, but it's very likely that whatever company you join, they're going to have some old project. It's been in GitHub for 10 years or whatever. Well, maybe 5 years. And in that case, they would still be using master as the branch name, because for the longest time, that was the default branch name. But it's the same concept. This is the one that can always be deployed or is just deployed automatically. And then the other long-term branch is develop. So this branch merges into master, and it should not break. So no one actually codes directly on the master branch. The only way that the master branch gets updated is that you merge develop into master. So after you fully test the develop branch and you verify that it works the way you expect it to, and it's not going to just randomly throw errors and bring your whole company down, then you merge develop into master. So it should not break, because this is, the last stop before the master branch. You can't deploy new code unless the develop branch is working correctly. And this is where you branch off of for creating new features, which we'll see that in just a second. So it's definitely bad if the develop branch breaks, but it's not like an immediate crisis. Like if the master branch breaks, like that's an immediate crisis. Everyone stops what they're doing and then fixes the master branch until you're good to go. And then you can resume your regular, work. If the develop branch breaks, like you can't publish a new version, but it's not exactly the same kind of crisis. It's not like all hands on deck, stay up late at night until you get it fixed kind of deal. Like you figure it out in the morning. So now the short-term branches, this is where all the actual coding happens. There's 3 types of short-term branches. Most of your work is going to be on feature branches. These are named like feature / whatever. So feature / add login page, or feature / validate phone numbers. Just whatever like business value this branch is trying to accomplish, you put that in the name of the branch. And now the way that we create these is we branch off of develop and then merge into develop. So, you would check out develop and then type git branch feature / whatever, and that's how you create your new branch. So develop is always the starting point for new branches. And then when you're done with that feature, you merge it back into the develop branch. So that's what you do normally when everything's going well, but unfortunately, things are not always going well. Sometimes you get bugs, and so you need to create a bug fix branch. Those are named like bug fix / whatever, like bug fix / login 500 error or whatever, something that describes the error that you're trying to fix. But this is actually a similar workflow to the feature branches. This is if it's a low priority bug. So it's not going to like bring down your whole company immediately because you've got this bug. Then you basically treat it like a regular feature and you handle it with your regular process. You know, you don't like stop everything you're doing. You don't trip over yourselves trying to fix this bug immediately. You just go through the regular process. You create a new branch off of the develop branch, fix that bug in your new branch, and then merge it into develop. And then when develop gets merged into master as a part of just your normal workflow, that's when the bug gets fixed. So you're not going to deploy the fix for this bug ASAP. It's going to get deployed when you do your next regular deployment, because you're just branching off of develop into develop, and then develop gets merged into master with some regular cadence. Maybe it's every week, maybe it's every other day, or maybe it's every other week. Maybe it's every day if your company is insane, but you're going to have some regular cadence for merging develop into master. So the last type of branch, this is called a hotfix branch. And so you would name this, hotfix slash, and then a brief description of the issue, like hotfix slash homepage is down. That is definitely like a hotfix kind of issue. You cannot wait to fix that. If your homepage is down, like nothing else matters in your application, you need to fix that before you do anything. So in this case, because we know that the current live deployed code is like on fire and needs to be fixed immediately, you branch off of master, merge into master. You do that immediately. It bypasses your normal workflow of everything gets merged into develop first and then develop merges into master, because this is such a high priority issue, bypasses the normal workflow and gets merged ASAP. And then afterwards, once the dust has settled, you can apply that same bug fix to the develop branch, and then you merge develop into master, and then you get back into your normal flow of things. But so generally speaking, in a dev team, these are the only types of branches you have. So you're going to have 2 branches and then maybe a dozen or so short-term branches just to represent the work in progress that your teammates are doing. Ideally, you shouldn't have like a graveyard of dozens and dozens of short-term branches. That means that someone is forgetting to delete old branches after they're no longer being used. You should only have a small number of branches for the features that people are actively working on. So like in theory, I could at my terminal, type git fetch and then git branch -a. And then that should give me kind of like a quick snapshot of what my coworkers are working on, because I'll just see all of the remote tracking branches from their work on our repo. So yeah, that's kind of the basics of how people work together with Git. I expect for your personal projects or for your group projects, you're probably going to do something similar to this. You might not need quite this level of structure. So like it might not be useful to you to have a develop branch. You might just have everyone merge into master, given that you don't actually have a staging environment. You don't have like a QA department. So you might not actually benefit from having this extra layer here. But certainly for professional teams, practically, I think it's really essential having this extra branch, not just having master, but also having develop. All right, what questions do we have? No questions? All right, so if we don't have any more questions, then I'm just gonna thank you all for coming to my talk, for your time and attention, being engaged, following along. Hope we all learned some cool stuff about Git. And I'll see you later then.